Hey everyone! Welcome back to ZoomInData. And this is episode 25 of our KQL Concepts Deep Dive series. Today we are exploring Union, how it merges tables, handles schema evolution, and deals with heterogeneous data. We are keeping everything pure concepts and interview focused. If you missed episode 24 on join flavors, it's a good one to catch up. Let's get started. Here is our roadmap for today. Union combines rows from multiple tables vertically, stacking them. Schema evolution. Columns added or removed over time are handled gracefully. Union with different schemas produces the widest possible schema, union of all columns from all inputs. Missing columns are filled with null. No data is lost. Union with asterisk wildcard merges all tables matching a name pattern, very common for daily, weekly partitioned data. The key concept is append only, schema on read flexibility, perfect for logs, telemetry, and evolving data sources. Let's dive into how this works and why it's so powerful. Union basics. It appends rows vertically, stacks one table on top of another. Unlike SQL, order of columns doesn't matter. KQL matches by column name, not position. If the same column name appears in multiple inputs, it becomes one column in the output. No automatic deduplication. All rows are preserved. That's why it's union all semantics by default. Use union when combining the same logical entity from different sources, time periods, or partitions, daily logs, regional tables, legacy plus new data. It's the append-only mindset in action. Schema evolution is where union really shines. Tables evolve over time. New columns get added, old ones deprecated or dropped. When you union them, KQL takes the union of all schemas, the widest possible output schema. Any column missing from one input table gets filled with null in those rows, no data loss, no error. This is pure schema on read flexibility, no rigid schema enforcement like traditional databases. It's perfect for telemetry and logs where new fields, like new event properties, are added continuously without breaking historical queries. Union gracefully merges old and new without forcing schema changes. Look at this diagram. It shows exactly how Union handles schema evolution in KQL. On the left you have table A, classic columns, time, event, user. Then table B adds new fields, region and version. Schema is growing. Table C adds error code but drops user, real-world evolution mess. Union takes the widest schema possible, union of all columns, time, event, user, region, version, error code. See the arrows labeled schema union. They merge everything. Where a column is missing in one table, like region in table A or user in table C, it gets filled with null in those rows. No data lost, no errors thrown. That's the beauty of schema on read. Old and new data live together seamlessly. New fields appear in recent partitions, older ones stay null in history, perfect for telemetry where schemas evolve constantly. Union just works, flexible, forgiving, and production ready. Union with wildcard is one of the most powerful patterns in KQL. Union asterisk merges all tables matching the pattern, like logs _2025_03_ for March data. This is ideal for time partition tables, daily, hourly, or monthly shards. Schema evolution across partitions is handled automatically. New columns appear in newer partitions, old ones null in older ones. The engine prunes irrelevant partitions when filters allow, like timestamp greater than ago, 30D. Common production pattern, union logs _*, where timestamp greater than ago, 30D, summarize. Seamless merging of historical and recent data without manual table listing. This is append-only nirvana. Here are the trade-offs and pitfalls. Widest schema means output can have many null columns, harmless but can confuse downstream consumers. Pitfall 1. Union * on hundreds of tables without good pruning leads to high startup cost scanning metadata. Pitfall 2. Mismatched column types across tables means union fails or forces implicit casts, string to int, etc. Best practice. Always filter early, especially on time columns, so the engine prunes irrelevant partitions. For repeated union patterns, wrap in materialize to cache the result. Union is flexible and forgiving, but pair it with smart filtering and you get both correctness and performance. Look at this balance scale. It captures the real trade-off when using union in KQL. On the left pan, flexibility, green checks for schema evolution, new columns added over time, wildcard union, easy merging of partition tables, and that append-only power. Union just works with changing schemas, super forgiving for logs and telemetry. On the right pan, pitfalls, red warnings for lots of null columns cluttering output, no pruning, union * scans everything if unfiltered, and type mismatch risks, string versus int crashes or bad casts. The middle arrow says filter early plus prune. That's the key to tipping the scale toward flexibility without the pain. Add a strong where timestamp greater than ago, 30D, or similar filter right after union *, and the engine prunes irrelevant partitions fast. You keep all the schema magic and wildcard convenience, but avoid scanning old junk or exploding nulls. Union is incredibly powerful, but pair it with aggressive early filtering, and you get the best of both worlds, flexible schema evolution without the performance headaches. Why does this topic matter in interviews? Union is core to real-world KQL, especially in telemetry, logs, and append-only systems. Common questions include, how does union handle schema changes? Explain union * behavior. Why use inner unique versus union? Understanding schema on red flexibility and partition pruning shows production knowledge. It's critical for data engineering, observability, and ingestion roles. Explaining trade-offs. Widest schema versus nulls, wildcard versus explicit, pruning versus startup cost, demonstrates practical design thinking. Nail this, and you prove you can build scalable ingestion and querying pipelines. To wrap up, union appends rows vertically and matches columns by name, pure schema on read. It produces the widest schema with null fill, handles schema evolution gracefully. Union * is perfect for partitioned or time series data, automatic merging of shards. Always filter early for partition pruning, and watch for column type mismatches. This is the append-only philosophy in action, flexible, forgiving merging of heterogeneous sources without rigid schema changes. Master union, and you unlock one of KQL's biggest strengths for real-world log and telemetry workloads. That's episode 25 done. Thanks for spending time with me on ZoomInData. Next in episode 26, Parsing Semi-Structured Data, we will explore extract versus parse, greedy versus safe approaches, and how to handle JSON logs safely. Homework to lock this in. Explain to someone or out loud How does Union handle missing columns? Think of a use case for Union * in daily partitioned logs. Answer this one. Why is Schema on red important for telemetry data? If this helped, like the video, share it with anyone prepping for Azure interviews, subscribe for episode 26, and drop a comment with your biggest takeaway today. Thank you so much for watching ZoomInData. See you next time. Keep zooming in on those concepts. Bye for now.